Okay, let's go ahead and walk you through this review for your midterm. And remember, this is covering chapters 1 through 3 on this review, and then I have another review for the next half. So a radio talk show host asks listeners to respond to either yes or no to the question, is the candidate who spends the most on a campaign the most likely to win? 15 people called in and 9 said yes. What is the implied population? So who are they trying to gather data from? So I would say that probably all listeners of the radio talk show is who I would say that they're trying to get to. What is the variable? Well, let's see. We have 15 people called in and 9 said yes. So we're probably recording the opinion of a caller. We don't know the opinion of the listeners. They did count the number of callers, but they're not saying, okay, the answer is 15. They're saying who's saying yes and who's saying no. Can you detect any bias in the selection of the sample? Yes, voluntary response, because they just kind of put it out there and the subject has to go to the survey. They have to call in. So let's see how Mrs. Overman did on question 1. The suspense is killing me. Oh, there it is. All right, problem 2. So anyways, what you might want to do on your notes, make sure you know the different terms. I'm just going to kind of start writing them here. Whoops. Let's do blue. All right. So this is really a chapter 1 topic, which was the sampling methods and study design. This is Unit A. Okay, Unit A. All right. So you need to know sampling methods. So can you tell me what a simple random sample is? What is a stratified random sample? What is a cluster random sample? What is a systematic random sample? And you might also see convenient sample. All right. So that's the sampling methods. So make sure you understand these. And then what we just were talking about are sources of bias, right? So if let's see if that'll bold that. And then we have sources of bias. So we have response bias, non-response bias, response, voluntary response bias, and then under coverage. Those are the sources of bias. Okay. Oh, I think it's going to let me do some nice formatting here. And let me kind of highlight that. So that's a main category here. And voila. Voila. I don't need to number them. Order's not important here. Let me go ahead and add. So you might want to take some notes on these terms. And what we did is we had voluntary response bias. Let me add my note. When the subject comes to the survey. All right. So that's when the subject comes to the survey. All the other ones, the survey comes to the subject. All right. So maybe so under coverage, we actually do, I'll put that, well, under coverage, I'll put it in front. Under coverage, response bias, non-response bias, all of those, we are taking the survey to the subject. But on this one, voluntary response bias is when the subject comes to the survey. Okay, back to the questions. One cable station knows that approximately 30% of its viewers have TiVo and can easily skip over advertising breaks. You are to design a simulation. You guys probably don't even know what TiVo is, do you? It's like on demand. If you have like cable TV and a DVR, it's like one of the original DVRs. So I don't know if your house still has a DVR or if you're just doing streaming, but that's what TiVo is. So one cable station knows that approximately 30% of its viewers have TiVo and can easily skip over advertising breaks. You are to design a simulation of how a random sample of 7 station viewers would respond to the question, do you have TiVo? How would you assign the random digits 0 through 9 to the responses yes and no to the TiVo question? Hint, use your random digit assignment in the random number table to generate the responses from a random sample of 7. So we're going to do the digits 0 through 9. And let's see, our design, however, with random sample of 7 station, let's see, we're going to do a simulation, all right? So the main thing on a simulation, let me go ahead and add my notes. So simulation, this was one thing you did have to do. Oh, why is it black now? Oh, well, who cares? Simulation. You need enough digits to model the percent of successful outcomes, all right? And you need enough digits to model 100%. Note, this can be 1 or 2 or more digits, all right? It just depends. So you're going to make a fraction. Actually, that's probably a better way to say it. To model the number of successful outcomes, all right, and to model total outcomes. So this can be 1 or 2 or more digits. All right, so we are, in this example, we are trying to model 30%. If given percent, change to a fraction with a denominator of 10, 100, 1,000, or higher, as needed, all right? So you can change it to a fraction. So we're going to take this example. So our example is we have 30% of viewers have TiVo. So let me go back to here. Review example, review number 2 example. 30% have TiVo, which means that is 30 out of 100. But I can actually simplify to 3 out of 10, right? So I need to model, how many digits do we need to model 10? It's always one less if it's 10, 100, or 1,000, all right? We just need 9. I mean, 1 digit, sorry, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All of those are 1 digit, and how many of them do we have there? We have 10. And so we're going to take the first 3. By the way, so we have the 10 digits right here, right? I can take either this first 3 here, or I could say 1, 2, and 3, but then I have to tell you what to do with 0. So let's see what our options are on the question. So we need to pick 3 of these to represent having TiVo. All right, we could pick 0 through 2 or 1, 2, and 3. Be careful with 0. I know you can't see that. All right, so be careful with 0 on if you do that second one. I'm going to actually expand this just a touch. So it can, there we go. All right, so, oh my goodness. Just a touch, there we go. All right, so let's go ahead and look at our options. Assign digits, so 5 out of the 10 correspond to yes. No, we only need 3 out of the 10 to correspond to yes. Oh, look, it was very simple. They didn't even say which. So there you go. You're trying to model 30%. And so if we have 3 out of the digits say yes and 7 out of the 10 say no, which you could do with my notes right here. So you would say 0. This is how you would say it. 0 and 4 through 9 are no. And this is our yes. And what I'm going to do is just return right here. So this is the review example right here. So let me go ahead and highlight that in a color so you know that that is a review example. We'll make it green. Who doesn't like green? All right. So there you go. All right. So there's simulation. And that's some nice notes there. You're welcome to copy off of me. Okay. Then let's go back to our next question. I'm pretty sure this is right. Do not assign even digits to yes and odd to no, because that would change the percent to 50-50, and that would not work. Categorize the type of sampling: simple, random, stratified, systematic, cluster, or convenience, used in each of the following situations. To conduct a pre-election opinion poll on a proposed amendment to the state constitution, a random sample of 10 telephone prefixes, first 3 digits of the phone number was selected, and all households from the phone prefixes were selected. So this is a cluster sample. Why is that? So what you're doing is you're naming groups. So cluster sample, randomly picking whole groups. And telephone prefixes are a group. Prefixes, there we go, are a group. All right. Okay. So let's go back to our question. So we're going to say cluster there. To conduct a study on depression among the elderly, a sample of 30 patients in one nursing home was used. Well, they just kind of picked, they didn't show how they used randomization. So if they don't use randomization, it's probably a convenience sample when no randomization is used. So you got to see something about randomization on it, okay? And to maintain quality control in a brewery, every 20th bottle of beer coming off the production line was opened and tested. So I would come back to here, and that's a systematic random sample. Every nth individual is selected. All right. And I will keep the word wall up during the final, so you can go ahead and look at that if you need to. So that one is a systematic sample. Subscribers to the magazine Sound Alive were assigned numbers, and a sample of 30 subscribers were selected by using a random number table. The subscribers were invited, blah, blah, blah. So anytime you use a random number table and you're selecting, so you're selecting from number every individual and use random numbers to select. All right. And then let's see, so that's a simple random sample. All right, and then to judge the appeal of a proposed television sitcom, a random sample, 10 people from each of 3 different age categories was selected, and those chosen were asked to rate a pilot show. That's called a stratified sample. So how do we know it's a stratified sample? Basically what you're doing, it's like splitting population into groups, and then taking a sample from each group. That's how you know, okay? All right, let me go ahead and do that right there, just so we know those are. So, all right, let's go ahead and submit my answers. I'm fairly sure we're fine. Submit for testing. Okay, we've got 9. We are 20% of the way through almost. So, see, it's not so bad. Which technique for gathering data, observational study or experiment, do you think was used in the following studies? Explain your answer. The U.S. Census Bureau tracks population in 1900. The percent of the population that was 19 years old or younger was 44% in 1930. So they're tracking all this. So the question is, you can see we're dealing with an observational study or an experiment. Really simple notes. Observational study. Let's see if the types of studies. By the way, simulations are typically considered an experiment. So types of studies. Simulations are sort of an experiment, sort of. We have observational studies. Just track and observe. Can only say association. All right. Experiments randomly impose treatments, assign treatments, can say causation, whether there is or not. So that's what those 2 main types of studies are. Types of studies. All right, and voila. And so let's go back and look at our two choices. Our two choices were, this was, so we just tracked. So we know it's an observational study. We did not deliberately impose a treatment. We just kind of observations, all right? After receiving the same lessons, a class of 100 students was randomly divided into two groups of 50 each. One group was given a multiple choice exam covering the material in the lessons. The other group was given an essay exam. The average test scores for the two groups were then compared. So the students aren't picking what kind of exam they were given. They are randomly assigned, so it's definitely an experiment, and the treatment was deliberately imposed. All right, so let's go ahead and check our answers here. Excuse me. Allergies been horrible this year. Okay, next one. So you can see those are all correct, as they should be. Number 5. Suppose you're conducting a study to compare firefly populations exposed to normal daylight darkness conditions with firefly populations exposed to continuous light 24 hours a day. You set up 2 firefly colonies in a laboratory experiment. The 2 colonies are identical, except one colony is exposed to normal daylight darkness conditions and the other is exposed to continuous light. Each colony is populated with the same number of mature fireflies. After 72 hours, you count the number of living fireflies in each colony. So it's not like the fireflies are picking their conditions, so it's definitely an experiment. So we're going to say this is an experiment because a treatment was deliberately imposed on the individuals in order to observe a possible change in the response to the variable being measured. Is there a control group? Well, let's see. We have normal daylight and darkness conditions, and that's typically the control group right there. Okay, that's your control group. So control group is the group, let's go ahead and experiments. So experiments has a couple extra things. Control group has normal conditions, no special treatment. Might receive a placebo. They don't have to receive a placebo, but they might, okay? All right, so let's go back to your thing. Is there a control group? We said yes. Is there a treatment group? Yes, a treatment group has light. Pretty sure they got it 24 hours a day. Yes, 24 hours a day. The variable, what did we count? We were saying you count the number of living fireflies in each colony. So the number of fireflies living at the end of 24 hours. What is the level of a measurement? Oh, okay, so let me just do this. You're not going to experience this too much in the final. The measurement should be, let's see, did they just say, yeah, number. So this is nominal. Okay, so on that review question, here's side note. This should not be part of your final. Side note, nominal means number. All right, that was review problem 5, I think. All right, that should not be on the final. If it is, trust me, I will let you know. I'll make a note in this review near the top. Okay, yeah, so a lot of these questions I don't make, and we don't spend a lot of time on ratio, interval, ordinal. Ordinal is like order, ratio is a fraction or percent, nominal is like number. And we haven't even really dealt with intervals. Well, intervals could be like a category, like if you're saying, oh, grades from 90 to 100. So see, you got some review either way. So even if it does show up, you should be fine. Nominal is number. Ordinal is what rank. Interval is like a range of numbers, and ratio is like a percent or a fraction or a decimal. Okay. A consumer interest group is tracking I guess I should make sure I got these right? Because there is a weirdo question in there, so I want to make sure that's right before I move on. It could be so embarrassing, but it's not because I got them all. Number 5, okay, that's one. Oh, I didn't, wait. What is a variable? Oh, embarrassing. All right, so we got this part. What is the variable in the study? Okay, I'm going to say it's the amount the fireflies receive. And are we going to do a ratio then? Let's see if it's a ratio, like a percent. Let's try that. That was embarrassing. Let's see. And I'm going to reread that question. I kind of skimmed through it. Okay, something's going on with 5. Let's go see. The way the fireflies react to different conditions. Okay, you set up 2 firefly colonies. 2 colonies are identical except one is exposed to normal daylight darkness conditions and the other is exposed to continuous light. With the same number of mature fireflies. That's why they did ratio. Technically, it was the number. I'm sticking by that. But I guess after a while, you're going to count the ratio that are living. They did not say that. So I think that's a badly worded question. The variable of the number of fireflies, did I click 72 hours instead of 24? Maybe that was it. Maybe that was a weirdness. Let's try that. It was 24 hours, right? No, it was 72 hours. Is that what I'm doing wrong? Let's go see. Yeah, I think that's 72 hours. I think I just clicked the number wrong, the wrong one. So what happened there, and I'm fairly confident this is right. Yeah, okay. So Mrs. Overman was not reading carefully between the multiple choice questions. So we actually let the fireflies, we watched them after 72 hours. See how that 24 hours threw me off? Be careful with that kind of thing. And then we have ratio. Again, I don't think that's cool because they did not say the percent. It's implied because you had the same number of French fries. So fireflies. Now I'm starting to Freudian slip. So I'm issuing my complaint. So a consumer interest group is tracking the percentage of household income spent on gasoline over the past 30 years. Which graphical display would be more useful? A histogram or a time series graph, and why? So let's see. I think I'm almost done with this page. Let me see. How much space is there? Oh, I think I can fit types of displays. So this is all our notes for Unit A. So let's start a new one. I'm going to kind of copy this. Control C. And B. Oh, now it's doing green. That's so weird. So let me throw this away. And we're just doing normal notes. Come on. So graphical displays / organizing data. And this is Unit B. Hey, look at that. We're already to Unit B. Doesn't that feel great? Okay, so let's go look at our question. So we have a couple of different displays. We got histogram, we got time series. So let me just go ahead and list those out. So we have categorical displays, which are, you've got bar graph, let's see, pie chart, also circle graph it might be called, usually a pie chart. Let's see, two-way table in general. So I'm gonna, these are gonna occur to me because I'm like going off the top of my head. Why does it throw that little shading there? I don't know why. Oh, let me zoom so you can actually see. So sorry. Then we have quantitative. So this is for numerical data. And there we have, actually, let me do a little dot plot here. Oh, that's weird. That's interesting. Okay. So I wonder if I can do this. Control C. And I hate this shading. It bugs me. There we go. The shading just bugs me. I don't know why it's shaded. Okay. Thank you for putting up with Mrs. Overman's picadillos. Okay, so this is the big one. All right. So we got categorical displays. Bar graph, all this. We've got quantitative data displays for numerical data, and those include time series, which really should be last. I'm going to save it for a second. Dot plot. You should know what a dot plot is. We got stem plot, what Mrs. O uses for test grades, although I don't do it that much for you guys. And then you've got stem plot, dot plot, You do have time series. Oh, you have histograms. That's kind of like a bar graph. Histograms. Sort of a bar graph for quantitative data. And I pretend I can write. All right. So that's what a histogram is. And so categorical displays are for categorical data. That hopefully is obvious. All right. So let's go back to our question. The percentage of household income over the past 30 years. So time series is definitely better. We're trying to look at the change in data over time. The range of values for the data, see how this does not have over time in it. So we're trying to look over time. So when you want to look at data over time, you want to use a time series. So use when you're looking at the change of data over time. Okay, so that's how you know that one. Okay, so and I'll submit that in a sec. Let me do this one. Describe how data outliers might be revealed in histograms and stem and leaf plots. So another thing we need to know is what are outliers. So outliers, quantitative data only. All right. So they're unusually high, low, or high values. The formula to find it, lower boundary equals 1.5, I'm sorry, Q1 minus 1.5 times IQR, right? And where IQR is equal to Q3 minus Q1. Upper boundary. Now, we're not going to calculate it on this example, but since I'm on these notes, I might as well go ahead and put this up for you. And it's the same thing, IQR, so ... So if you ever see something like this with a bunch of quotes like that, where IQR, that sort of thing, basically it means ditto the thing above it. All right, you might see that in college when you go to college. It's very soon, it's on the horizon. So how might they be revealed in histograms and stem and leaf plots? Basically, any large gaps between bars or stems might indicate potential values. So the problem with the first one is it just says large values, but you can have big outliers and you can have small outliers. Same problem with the bottom one. Large concentrations of data. No, it's very small concentrations of data. So usually spot by looking for large gaps between the value and other data. All right, what was the other thing they said? They said large gaps, small values can be high or low, I think is what I should tell you. Outliers can be high value and usually low or high values. So I already have all that. Okay, so that's outliers. All right, and this is how you mathematically calculate it. So let me go ahead and save while I'm thinking about it. Oh, good, all changes saved. So let's go ahead and check our last two questions, 6 and 7. We have 10 questions left. You're probably going, oh, but look, we've done 18 out of 51. We're like a third of the way through. So let's go to question 8. You can see I got those two right. Commercial dredging operations in ancient rivers occasionally uncover archaeological artifacts of great importance. One artifact is Bronze Age spearheads covered from ancient rivers in Ireland. A recent study gave the following information regarding discoveries of ancient bronze spearheads in Irish rivers. So, make a Pareto chart. Ah, that's one of the ones I was missing. Pareto chart is a very special type of bar graph. So, we'll say Pareto chart. Descending order. All right, you got pie chart, bar graph. Those are mainly it. Looks like a histogram. but no numbers on the for the columns, for the type of columns, right? So, and I'll show you what I mean. So when we're going to this problem here, you can see I don't have numbers down here. If this was a histogram, I would have a starting number and an ending number. So histograms, each bar has a starting and ending number. All right, so that's how you can kind of tell them apart. Let's go back to our question. So the best way for me to do this, if I'm going to take the data, is put them in descending order. So I can go to Staplet here. And so this is going to be a little bit harder because I have to put them in descending order, but I know you guys know ascending and descending. So we have one categorical variable, just one group of data. And we're going to look, what was the highest value here? It was Shannon, whatever that is. So I'm going to type in Shannon, and there are 30 of those. All right. And then the next highest one was 25 for Bon, B-A-N-N. Oh, pretend I can write. There were 25 there. We had a couple more. Let's see, the next highest one was 50. Ernie, it looks like. But it's not quite Ernie, it's something else. And then we had a 14 on Barrow. So you'd probably, if you were doing this while you're taking your final, I would have a small piece of scratch paper because I know you're switching back and forth. And then Blackwater is 10, the smallest. So you could write those down, and then you could create your chart. So this is a bar chart right here, also known as bar graph. And I forced it into being a Pareto by specifically putting the data in order. So then it asks, which one of these is the one below? So now look at it says, so this has total number. So there are a couple ways to do this. You can make this a relative bar graph by saying relative frequency, and then it changes it to percents, but it just has number there. So we'll just put back frequency. Remember, frequency is just the number. So uses frequency, the number of data points. Quantitative displays don't really have a frequency per se. You don't enter it like an actual data point like I did up here. See how I had to enter it? Frequency. All right. So if I look at this picture, so we got Shannon, Bon, Ernie, Barrow, Blackwater. That's probably in their 30, 25. So 30, that looks the most like it right there. Now make a circle graph of these data. Oh, goody. We just go here, hit pie chart. So let's see, make sure that Shannon is at 31% or 32%. Bon is at about 27%. So let's look. Shannon, we said, was 32%, right? And that one looks like it. Be careful with these things. They're down on the bottom right. Yeah, let me double check on my bar chart, pie chart. Shannon is 31.9. See how it pops up as I'm over the thing? So you can double check that. And then let's go ahead and submit. Okay, 20 out of 51. We had to do a little bit of work for that one, didn't we? Might want to save these for the end. All right, how are dot plots and stem and leaf displays similar? They show every data value. So that is something that they both have in common. They do not have nothing to do with time. And it's definitely not categorical. They're quantitative. How are they different? Stem and leaf displays group the data with the same stem, whereas dot plots only group the data with identical values. That is 100% true. Both of these show every data value. Neither one has anything to do with changes over time, and there are no categories in here. We have answered the following questions based on the figures below. So we have fuel economy standards for autos, and you can see it's got this cute roadway. And then we have required fuel economy standards. So same idea, except now it's shown here as a time series graph. Look at figure A above. Is it essentially a bar graph? Yes, it is. You can see how many years something, or you can see how many years are here, and then you have how many miles per gallon as the years go by. So we're going to say yes there. And then the question is, but this is a bit flawed. What's the problem with it? The years are evenly spaced numerically, but the problem is, so 82 to 83, you see how 83 to 84 seems wider? It looks like they're using the little dashes as the bars. I don't know. But you can see these bars are not the same width. So that's a problem, all right? Even though the years are the same spaces apart, and you kind of lose some of the ability to compare the bar heights, it's a little bit harder to do that. Then if we look at this, they're going to compare to this one now. Same information. This is a time series graph because you can see here's the time and there's the dots connected. And so not a scatter plot, but a time series plot. And it shows the years on the x-axis and the miles per gallon on the y-axis. Okay. In what ways does figure B seem to display the information in a clearer manner? You can see how fuel economy standards for new cars have changed over the 8 years shown. So you can see that the fuel economy's gone up. It's more easy to see that. And everything is to scale and not distorted visually. So we'll go ahead and submit that for testing. And we got them all in number 10, so we'll go on to number 11. Many people say the civil justice system is overburdened. Many cases center on suits involving businesses. The following data are based on a Wall Street Journal report. Researchers conducted a study of lawsuits involving 1908 businesses ranked in the Fortune 1000 over a 20-year period. So make a Pareto chart. So basically, I'm going to do the same thing I did last time. Let me go ahead and reset everything here since we fixed that. And I just need to make sure I put in my data. Now, I could just kind of come in here. Do I really need to enter the data? I know I need to see general torts first. So it's not B here. It's general torts. So we know it's either this one or this one. And then let's just make sure we have the right number. Oh, this one has the right number of general torts. So I didn't even have to make a graph. Which type of cases occur most frequently? Well, it was the general torts. You could look at the table. You could look at the Pareto chart. Make a pie chart showing the percentage of each case shown. So what I could do is I could take the one that I'm going to go ahead and do this because it'll tell me the percentages automatically. So general torts, actually, I don't need to do it in order, so that makes life a little bit easier. Contracts 107, general torts 191. 107, general torts, 191. Oh, let me get rid of that dash in case it doesn't like that sort of thing. And let's see what's our other data we had to put in. Asbestos, 49, other, 38. Asbestos, 49, other is 38, and then there's one more besides other, which is interesting. All other. All right. So it's other product liability. Liability and all other. And I forgot to look at the number there. Hold on. All other, because I was surprised it was another 21. All right. So if we begin analysis here. So you have this. You can actually slide over it, but we want relative frequency, or I can look at relative frequency right here. And what was the question? I think it was about general. Oh, we were trying to figure out general torts we know is 47%, I'm pretty sure. Here, let me scooch. Why is this not showing the whole thing? Here, let me scooch it. Well, all right. So you can kind of see it here. All right. And so general torts 47, 47, 47. So it's not that one. Let's go back to our data. Contracts is 26.4. Contracts 26.4. So that one's good, that one's good, and that one's good. So these three are fine. What's different over here? We've got other liability. Other liability is different. So let's just look at other liability. 9.4%. So whichever one has other liability, was it all other liability? Hold on. All other. Wait, is that all other? No, it's other liability. Oh, so they kind of did the same thing I did. Wow, that's funny. So other liability, 9.4% is what it should be. So other liability, 12, so it's this one. All right. So when I scroll down, hit submit for testing, and I'll bring this back in width so you can see, we got all of those correct. Beautiful. Number, you know what? I'm going to go ahead and pause here because this is, and then we're going to do 12 through 17 in just a second. It'll be a second video.